Now, repairing the chair here, I'd seen it had been put together with screws there. Screws were put in to reinforce the joints there when the joints became loose. And these are the old steel screws that we would have used from the time I started in this game back in the 70s. The old steel screws kind of brings up a bit of, I suppose, a bit of nostalgia for them, and a love of the old wood screw because of their strength and their holding ability in comparison to the modern screws we have. So the steel screws, just a comparison between them is the standard ones we have are normally posi drive. This is just the Spax version there. You see there the 5x60, and just the sizes of them. Just to go through them. This is the modern metric system. Now if I hold that there like that, the metric system shows 5x50 there. So it relates to millimeters, and the 50 mil is the actual length of the shank. And the head of the screw there, if you measure it across with a tape, you'll find that that's 10 millimeters across. And we half that measurement and we get 5. So you get the 5x60, and you notice the 5 comes before the 50, I mean. So it's 5x50, so it's half the diameter in millimeters, and we get a whole number then, 5. So 5x50 means the head of the screw is the 5 and the length of the screw is 50. In actual fact, the head of the screw is 10 millimeters across. So that's how the size is determined with the new screws. Now it just so happens the screws I'm taking out, I would still know the sizes and the gauges of these from all them years back. So this is a 2.5 inch 10, and you notice that the 2.5 is mentioned first. It's not like the 5x50. We would call them 2.5 inch 10s. And it just so happens that I have a box of them here. So I have some old steel screws, and you can see the old boxes. These are probably, God knows, I don't know, 30, 40 years old. And I would use them for working on old antiques and so on. So you see there that 200, and it's barely illegible there. It's 2.5 by 10. They're the imperial measurements then. So if we look at the imperial system, which is what we would have been using back in that day, the imperial system was 16/16 was equal to an inch. And if anybody doesn't understand that, when you look at the tape, we'll bring that up close. So an inch, that's an inch there, and if you see all the individual little fellas here, there's 16 of those guys between 1 and 2 in that case there. So there's 16 16ths in an inch. Now there's 30 seconds in between them, final measurement again, but we don't need to go there. So we'd always say 16/16 would be equal to an inch. So we use that then for the basis of the screw. In this case, this particular box that I have here is 2.5 inch number 10. Now the 2.5 inch is no bother, that's the actual length of the shank. So that's 2.5 inches. If we measure that, just for showing people on camera, so there's your 2.5 inches in length. So that's that there. When we come to the head, what we do with the head is we measure that in inches also, but we look at it in terms of 16. So that's 3/8 there of an inch. So we've 3/8 there, which would be what's it? 1, 2, 3, 4, there'll be 6 16ths. So we 3/8. What we do there, if I'm doing this right, we have 3/8 of an inch there, which is equal to 6/16. So we double the number there. 3/8 is, we double the number and we get 6/16. 2 3s is 6, 2 8 16. Then we subtract a 16. We subtract 1/16 from 6/16, and we get 5/16. And that now becomes, we multiply that by 2 and we get 10. So that's where we get the actual finished size from, 2.5 inch number 10. So again, just to reiterate, it's a bit more complicated than the older system, the imperial. The reason I would imagine is that they wanted whole numbers, 2.5 inch number 8s, 2.5 inch number 10s, 2.5 inch number 12s. They went up in increments of 2. So in order to have even numbers going up along, that was the way of working it out. So they would take you'd convert everything to 16ths. 2.5 inch was the length. So the 10 in this case, we had it's the width of the diameter in inches. So we take it as 3/8 of an inch when we measure it across. We convert that into 16ths, which is 6 16ths, and we subtract then a 16 to give us a number 5. We multiply that number then by 2, and that'll give us 10. And that gives us the size of the imperial screw, 2.5 inch number 10. That's how it was determined. I'm not sure who thought it up, But anyway, the 16ths, it works for every screw type for the imperial system. So that's the difference between metric and imperial. And you'll note that in the imperial system, the longer length came first always. So the length came before the head size. In the metric system, the head size comes before the length. Now, it might be useless information to a lot of people, but it's just, we had to know them when we'd be getting screw sizes. When we'd say to the boss, he'd say, what size screw do you need? And we'd say, we need 52.5 inch number 10, or we need 1.25 eighths. So we'd have all our sizes banged in, we'd know about them all the time. And that's how they were determined. So, hope that's useful to somebody, or a useless piece of information, probably lots of people, but there you go. It's only while I was doing this little share that that little thought came up, and I thought I might explain it just on video. Okay, over and out for now.